a single test tunnel, and that is the single test hammer that goes past the gate. So this is a Fathom S40 turbidity instrument, and what it does is it measures the clarity of the river water, namely how dirty it is, and it measures it as a raw reading, electronic reading, and which we then convert to an NTU unit, which is a unit for turbidity. It's got 4 prongs on it, and there is an infrared signal between the 4 prongs, and if we lose 1 prong it doesn't matter, if we lose 2 prongs it doesn't matter, and therefore it's got a lot of redundancy within the instrument. And in a river that's really important, because what happens is things grow on it, or you get snails in it, or things are affecting it. This tube around the outside we've had to fit, because the instrument, being infrared, is affected by sunlight, and even sunlight that goes through water is reflected off the water. So this is called a stilling tube, and we've had to make this stilling tube and these Heath Robinson fixings on it to fix it in place, and then we place it in the river, and this gives us a reading about every 10 minutes of the clarity or the turbidity in the river. These instruments have a communications cable, and that cable goes right into the river and up the riverbank. And when a storm comes along, it sweeps the cable away and things will fall on it or hit it. So what we're doing at the moment is using an old garden hose split in half to act as what's known as armouring. It's a mechanical armour to the cable to at least offer some level of protection, so if it gets hit by a rock or something it will still keep working during the storm. But it works pretty well. It stays in place, certainly during big storms, as we've discovered. We're measuring the turbidity because it's important to understand how the river behaves under different storm events. Every storm is different, and it's not always the biggest storm that carries the sediment, and in fact we're finding it's actually quite small storms that carry a lot of sediment, and we're hoping that over time we'll get a baseline for the rivers, and then as we do intervention processes like planting in the wetlands, then that will reduce the amount of sediment coming down, and we can prove that using these instruments. The sediment, apart from causing blockages in the river systems, it reduces the amount of light that gets into the river, it reduces the oxygen in the river, and those two things can affect the life in the river. And then as you go downstream, it starts affecting the estuaries, Cowal Bay and the Hauraki Gulf, and therefore sediment is the biggest challenge we have, and also the biggest contributor to adverse effects in the water environment.